The first thing you want to do when you're graphing square root equations is find your starting point. And before, when we were finding vertex and point of inflection, we were putting that point in the middle of our table, because the starting point is literally the starting point of the graph and everything goes off in one direction, we now want our starting point to go in our first column of our table. So I just want to remind you, this is what our kind of our formula looks like, and the starting point is where the letters H and K will be. So we're going to get an ordered pair. If you look at this first question here, this is really like writing x minus 0 plus 4. So since there's a number missing, you know it's a 0. So our starting point for this problem would be at the point 0, 4. So that's going to be the first thing we put on our table. It also asks us to find the transformations. All that's happening to this graph is that it's being shifted up 4. So now you're going to put the equation, the square root of x plus 4, into your y equals, into the calculator. And then you're going to go to the table, and you'll notice that for the x values that are less than 0, so -1, -2, -3, you get an error. And what that means is that there isn't a graph there, which is why we chose 0 as our starting point, because that's where the graph starts. So I'm going to fill in the rest of these points here. So I have 0, 4, which I already knew, 1, 5, 2, 5.4, 3, 5.7, and then 4, 6. So now I'm going to plot these points. So 0, 4 is here, 1, 5, 2, 5.4, 3, 5.7, and then 4, 6. So here are my points. That's what my graph looks like. Remember that when we do domain and range, your values are already determined. The ones you're going to use are the ones that we got from our starting point. So this is what I'm going to use for domain. This is what I'm going to use for range. So I know I'm going to use 0 and 4. And then if I look at my graph, it is not reflected. So that means both of my signs are going to match the arrow of my graph. So they'll both be greater than. And then lastly, end behavior, we will always be going x towards negative infinity, and then my arrow is also going up. So then my y value also goes to infinity. For problem 2 here, the first thing I want to do is identify the starting point, which is positive 3, 0. So there's no k number, so if you add it in the plus 0, you can actually see it. So that's going to be the very first thing on my table. The transformations that are happening, there are 2 of them. This 2 right here tells you that this is going to be stretched. And then the -3 tells you that the graph is shifting right 3. So when we graph it, we'll be able to kind of compare to what we know the parent function looks like. So now I'm going to type this into my calculator, and so I can get my table of values. Remember that we chose the starting point, so that because everything below the starting point is going to give you errors for the y value. So 3, 0 is my starting point, and then I have 4, 2, 5, 2.8, or 5, 2.8, 6, 3.5, that one I rounded up a little bit, and then 7, 4. So now I'm going to plot these points. Okay, 5, 2.8, 6, 3.5, and 7, 4. So you'll notice that now instead of starting at 0, 0, it started 3 to the right. And also it's a little bit, it looks like it got stretched up, like it's taller now than it was before. Usually it's a little more flat than this. Okay, for domain and range, remember that we're going to be using our starting point. So I'm going to be using 3 for my domain and 0 for my range. This graph is not reflected. That means that both of my inequality signs will match the arrow, so they'll both be greater than or equal to. And then for my end behavior, x always goes towards infinity. Since the graph is going up, it's not reflected, it's also going to go towards positive infinity. The starting point of this graph is -1, -2. And that's going to go on my first line of the table. The transformation is happening in this graph because there's a negative in front. I know it's being reflected. And then it's going to be moving left 1 and down 2. So now you put this into your calculator, and we're going to fill in the rest of the table. So my points would be 0, -3, 1, -3.4, 2, -3.7, and 3, -4. So then if I plot my points, 0, -3, 1, -3.4, 2, -3.7, and 3, -4. So from my starting point, now my graph would look something like that. For domain and range, remember that your starting point numbers are always going to be what you use. So this will be x and -1, y and -2. And because this graph is reflected, my domain will match the arrow, but my range will be the opposite sign, so less than or equal to. And then my end behavior always goes towards infinity for my x value. But now since it's reflected, it's actually going down for the y values, so my y is going towards -infinity.